Wonderful. Now, without further ado, let's jump right into our very first lesson where we'll focus on computer hardware and software. And this is going to be imperative to understand, although basic, because it's going to lay the foundation as we move through this course. So what exactly do we have in store for today's lesson? Well, first of all, we'll kick things off by understanding and reviewing the technology roadmap thus far. Also, note that I've included timestamps here in the event that you would like to fast forward to certain topics. Then we'll move on to hardware and software. It is imperative that we understand the importance of hardware and software, especially the software side of things, given that this is a coding and technology course. A lot of what we will be doing in future is going to be based on software. And then lastly, we'll wrap things up by having a look at modern technologies currently available in industry. And this includes innovative and disruptive technologies. Wonderful. Now here is just a quick fun fact. Did you know that your phone carries way more computing and processing power than the computer that first sent astronauts to the moon? If you think about how far we've come, that is actually really insane. And here we go, our very first topic of the day, the technology roadmap. So without further ado, let's dive right into it. Now, who exactly was the first ever computer programmer? Well, her name was Ada Lovelace, and she was actually a brilliant mathematician as well as a writer. Now, while Ada Lovelace was the first computer programmer, her work was largely based on that of Charles Babbage in 1837, who developed the first programmable computer. However, hardware and software back then is not as we know it today, and technology has come a long way since the 19th century. Even today, the most inexpensive mobile devices are way more powerful and way smaller than the most capable computing devices back then. And these are devices we carry around in our pockets every single day. Add to this the birth of the internet, and we now have an interconnected network making our computing devices so much more powerful and intelligent. Now fast forward to the 20th century, and it's companies like Microsoft and Apple that have currently revolutionized the personal computer market and are the organizations dominating this market. These systems were versatile and could perform both personal and organizational tasks, which only spurred the adoption of the new technology. These companies soon became the tech giants as we know them today as a result of constant innovation. And it was not too long before other industry tech giants soon joined the arena by leveraging modern technology. Now, these industry tech giants are companies that you are most likely familiar with, and this includes companies such as Google, Facebook, and Uber. Google is the world's leading search engine and has indexed most of the internet. Facebook, on the other hand, is the world's biggest social media platform and currently owns WhatsApp as well as Instagram, two other popular social media platforms. And then lastly, Uber is the world's biggest and most popular e-hailing service, and what has made Uber such a success is that Uber actually does not necessarily own any vehicles. They essentially just link customers with drivers. And here is just another quick fun fact. You may be wondering about the first time the Turing test was ever passed. Well, that supposedly happened at the University of Reading back in 2014. Eugene Goostman, a program that simulated a 13-year-old Ukrainian boy, convinced a panel of judges into believing that it was a real boy during the course of a 5-minute conversation. And for those who are wondering what the Turing test is, it is essentially the capability of a program to illustrate or demonstrate human-level intelligence. Now let us actually move on to the second core topic of today's lesson, and this includes computer hardware and software. Now let's start off by having a look at peripherals, also commonly known as computer hardware, which consists of a variety of devices, and this includes both input as well as output devices. Even our mobile devices are considered hardware, just not as powerful or as complex as that of a personal computer. Especially when you consider high-end machines built for gaming and Bitcoin mining. These machines are a lot more powerful in terms of the computing power. Now, just a second ago, we did mention that peripherals or computer hardware consists of both input as well as output devices. So what are some examples of input devices? First of all, we have keyboards and keypads, which is often used for typing characters. We also have such things as a computer mouse, which is often used to navigate the user interface of various software packages we use. This includes things like Google Chrome, Microsoft Word, you name it. Microphones is just another popular example, especially when used for tasks such as podcasting. And take it from me, it's a worthwhile investment if podcasting is your thing. And then lastly, cameras is just another example of an input device. Cameras are also considered an input device given that it captures and processes images taken through the lens. Excellent. Now let's move on to some examples of output devices. And this includes things such as monitors or even your smartphone screen. And this makes sense because it outputs visual information to the user. We also have printers, which is pretty much self-explanatory. And then lastly, we have speakers that output some audio. Now, sometimes these devices can be both input and output devices. A camera, for example, allows you to capture images, which is considered an input, and sends images to a laptop or a personal computer, and this is considered an output. So therefore, it can kind of be both. The best way to distinguish between the two is to ask yourself if you are inputting information to a system or retrieving it. This information exists in various formats, and this includes text, image, audio, and even videos. Now let's turn our attention to software, and let's have a look at system software first of all. So what exactly is system software? Well, system software is one kind of software that makes up the entire architecture of a system, whether it's a laptop, a smart TV, or a smartphone. Now, system software can be thought of as the underlying software that powers the application and productivity software. So in essence, your system software would generally be your operating systems, and this could be Android and you name it. Okay, there are a ton of operating systems available to users out there depending on what it is that you want to achieve and the environment that you would like to work in. Now let's have a look at some examples of system software. Now our first example over here is just Microsoft Windows OS, which stands for operating system, and you'll often find these operating systems installed on your laptop brands such as Samsung, Asus, Dell, Acer, and so on. Next up, we have Mac OS, which is exclusive to Apple's products such as the MacBook or the MacBook Pro. And then lastly, we mentioned before Android, which is not necessarily exclusive to just one device, but available on a ton of devices out there. Android makes up a big portion of the operating system installed on mobile devices around the world, well over 60%, believe it or not. Now, what about application software? Well, application software is a lot more common than system software, and it's also more widely available out there and basically comes from a ton of developers, not just your Microsofts and your Googles, okay? Now, it is often developed by companies and developers to achieve some sort of process or task. For example, apps hosted on Google's Play Store and even Apple's App Store are considered application softwares. Now, you can think of these as your day-to-day applications that don't necessarily contribute directly to your day-to-day productivity or workflow. Excellent. Now, let's take a look at some examples of familiar application softwares out there. Now, once again, these examples might look quite familiar to you, and here's a couple of examples of application software. So Uber is definitely one. This is one we mentioned earlier. Google Chrome is just another example of application software. And then Google Music Player, which is now discontinued, unfortunately, because this used to be my favorite music player application software out there. One thing you'll realize is that they don't necessarily contribute to your productivity. So what about productivity software then? And how is it different from application software? Well, when it comes to productivity software, it's pretty similar to that of application software. In fact, it's still considered an application. If anything, productivity software is actually a subset or type of application software. This type of software is generally used to improve productivity and workflow of individuals within an organization, or even used to automate manual tasks. So we tend to categorize these kinds of software much like we do with other software, such as games or even ebooks. I'm sure you are quite familiar with this, especially on Google's Play Store, for example. Let's have a look at some useful productivity software tools that you could use as a software developer. Now, in my opinion, these are some examples of some of the best software tools out there that you can actually use to enhance your workflow as a software engineer or software developer. So let's take a look. First, we have Just in Mind, and Just in Mind is essentially a mobile application or even a web application prototyping tool. One of the most powerful features in Just in Mind is that you can actually design logic, variables, data lists, master lists, as if the application works on a real device. And this is really powerful in the event that you actually want to sell your product or idea, or even bring a concept to life. Now, in module 2 of this course, I am going to introduce you to Just in Mind, where we will be working on a e-commerce mobile application. So I'm really looking forward to that, and I do encourage you to stick around and check those lessons out. Next, we have Trello. Trello is extremely popular among software development organizations that manage projects. Now, Trello allows you to manage the deliverables of any IT project, for example, that you might be working on. So you might have someone working in UX or UI. You might have another team working on the database or the back end. Trello allows you to manage all of these deliverables until you reach the end product. Next up, we have Atom, and Atom is basically a code editor for web applications. Atom is quite popular, believe it or not, and it's very close in terms of its features to Visual Studio or Microsoft Visual Studio. Now, in our last 2 modules, when we get to scripting and coding, Atom is going to be our preferred IDE as a productivity tool to write code. Now, speaking of software development, I believe this is an excellent time to discuss coding. So what exactly is coding? We've heard this buzzword over the last several years. Well, coding refers to the ability of a programmer to develop software for a designated platform. This includes Android or Mac OS, for example. Think about it like this. Humans don't speak binary. We have a hard enough time making sense of all the ones and the zeros. Conversely, a computer can't understand human language either. So in order for you to instruct the computer to perform a specific task, you need to design code that can be interpreted by the computer as an intermediary. This is the purpose of code. Coding is a form of writing instructions that isn't binary to humans, that is much easier to learn and interpret by humans, yet a language that the computer can still understand. In most cases, when writing programs or code, you will likely be writing code that is high level and one step removed from the binary code. This often means that you will write code in an IDE or an integrated development environment, which acts as an interpreter for the computer to understand the language. It's as if you are speaking to someone who does not understand native English. Instead, they only understand their native language. So in order to effectively communicate with that individual, you will often require an interpreter. Now, when it comes to coding, we'll often hear these 2 terms being used interchangeably, programmer as well as software developers. There are subtle differences and there are big differences and there are similarities between the 2. Let's have a look at the list of these similarities and differences. Now, programmers are very capable of writing code. They are pretty much like engineers and know how to build certain systems or even design certain systems. They are also excellent in translating requirements into code. First of all, what are requirements? Requirements are essentially the end goal when designing a system. A typical example of requirement is when a button is clicked, some sort of event needs to happen. Now, programmers, like I said before, because they have this engineer mentality, they are excellent at translating these requirements into the actual build. Now, programmers are also highly capable in a few languages, and this is because they are very focused. You'll often find that a programmer might be good in Java and C# or C, or Java and Dart and so on. Now, the reason for this is because when it comes to object-oriented programming languages, especially your high-level languages, there are quite a few similarities across these languages. Things like classes, inheritance, and polymorphism. Therefore, programmers refine their focus on just a couple of languages and they master these languages. Now, programmers are also more of a technician role. When we say technician, we can also refer to the term engineers. And the reason we say they follow more of a technician or engineering role is because they are highly competent when it comes to the technical aspects of programming. And then lastly, computer programmers are also responsible for writing, testing, and maintaining the source code. Now keep in mind, the source code is everything that the programmer develops or writes from scratch. This individual will always have to make sure that when writing the code that they are following the right syntax, best practice, and so on. They must also make sure that they are constantly testing the code to make sure that all standards are being met. And then lastly, they have to maintain their source code in the event that certain parts need to be updated. Now let's turn our attention to software developers. Much like programmers, software developers are also very capable of writing code regardless of the language. Now, software developers are very good at translating high-level requirements, and I think this is one thing that really sets them apart from programmers. High-level requirements here refers to understanding the bigger picture of why a system is being developed and built. Not just understanding the code, but understanding the processes involved in writing that code and what the end product and what the end process needs to achieve after designing a system. Now, software developers are also very capable of multiple languages and stacks. Software developers are not necessarily refined to understand one specific language. They need to understand a broad range of languages. This includes front-end and back-end languages. Typical example would be a full-stack web developer who needs to understand the UI aspect and the UX aspect. Not just that, they need to understand the languages. HTML, CSS, and JavaScript, for example, would be your front-end stack. Whereas with the backend, they need to understand things like SQL databases and PHP. Software developers also tend to have more of a creative and conceptual understanding of everything. So they are not just technicians. You can think as a software developer as mentors to programmers, and therefore they are more of a professional role. Now, what do we mean by professional role over here? Remember, as a professional in this industry, in the software development space, you need to be able to string together multiple stacks. Therefore, you are not just an engineer and you are not just technically inclined, but you also understand the business value of why things are being done. And then lastly, software developers are good at analytics, system architecture, and IT project management roles. And this just goes back to the previous point that was made earlier. These roles tend to be more of a professional role as opposed to just technical roles such as engineering or technician. Excellent. Now for the final topic in this lesson, we are going to be focusing on modern technologies such as AI, the 4IR, and all of these new terms that have recently come into play as innovative technology has really grown over the last couple of years. Now, most of us have heard of the second and third industrial revolution, in which electrical power as well as information technology were crucial building blocks in society, and this enabled us to advance technology. The fourth industrial revolution, however, is an era in which rapid advancements in technology through innovations have brought us closer to the digital world, and this includes things such as automation as well as smart systems. Now, this is often called disruptive technology. It's an area in which society has become even more invested in the use of technology to drive various processes to achieve specific tasks. And this brings us to the digital society. So the digital society is here and it's time to adapt. We refer to the digital society or digital natives as individuals who have adopted modern and advanced technology as a daily part of their lives through this term called technology diffusion. These technologies have become integrated with society to the extent that we rely on them to perform simple daily tasks, such as maintaining our calendar, or even some of the more complex tasks, which include using it at an organizational level to track sales and social media engagement. Digital natives are key to the adoption of disruptive technologies, and they often require specific skills and the know-how to make use of these technologies. Excellent. So what exactly are some of the characteristics of the digital society? First of all, they are key drivers in technology diffusion. And technology diffusion basically refers to the rate at which technology is adopted within a specific geographical location or even around the world. Secondly, they are heavily invested in the use of disruptive technology. Digital natives are often the ones that either design these technologies or they adopt these technologies as early adopters. They also focus on technology integration, especially within an organizational level. And then lastly, one of the key characteristics of the digital society is that they invest themselves in adopting digital skills. Now, this could be something like being computer literate or even learning how to write software from scratch as an engineer or a developer. Now, many of us have heard of artificial intelligence, whether it's good or bad. Now, one of the most promising technologies in the fourth industrial revolution is the growing interest in artificial intelligence, otherwise known as AI. Artificial intelligence allows us to perform predictive modeling, forecasting, and even automation of mundane tasks. Much like human intelligence, artificial intelligence allows for machines to learn and identify trends based on a given set of data, which allows for machines to take actions that maximize its probability to achieve a specific goal. Later in this module, we'll actually cover AI in detail in one of our lessons. Wonderful. Now let's actually take a look at some of the uses for artificial intelligence. Now, first of all, we can perform things such as predictive modeling. Now, what exactly is predictive modeling? It is the process of implementing and using data as well as statistics to make predictions of outcomes with data models. Data models can be used to make predictions of just about anything, from customer behavior, understanding stock markets, and even to predict an organization's expected earnings over a given period of time. This could be years, months, weeks. Predictive modeling is also known as predictive analytics, and the two terms are often used interchangeably. Wonderful. Now let's move on to forecasting. Forecasting allows organizations to make predictions about the future based on past events, pretty similar to predictive modeling or predictive analytics. There are three types of forecasting or techniques. First, there is qualitative, a technique that uses human judgment when hard factual data is scarce, and this includes data such as numbers. And this usually involves the use of knowledge systems. You can also perform time series analysis and projection, which identifies trends and patterns based entirely on historical data. And then lastly, we can also perform causal modeling, a technique used to identify a cause and effect relationship between two or more variables to make predictions. Now, as a last point of interest in terms of usage of AI, we can also perform things such as automation. AI is quite popular in the domain of automation, a process in which little or no human intervention is involved in carrying out a particular task. Take your smartphone, for example. Not too long ago, you would have to manually enter a PIN or password to actually unlock your device. These days, you can unlock your device simply by looking at your selfie camera, which uses facial recognition software. Now, just another exhilarating and interesting topic that we'll cover in this module is immersive technologies. Immersive technologies include those technologies that are able to simulate a real-world environment and increase our suspension of disbelief, making us feel as if we were actually present in the virtual world. The technology has gained massive traction in the virtual reality as well as augmented reality space, with major technology giants such as Oculus, HTC Vive, Microsoft, and even Facebook backing its immense growth. The Oculus Quest 2, for example, has been coined one of the most popular virtual reality headsets available today. So what are some of the types of immersive technologies available today? Well, first of all, there's virtual reality. And virtual reality, also known as VR, is essentially removing the user from his current real world, his physical space, and placing the user in a 3D generated world or even a computer generated world. The idea is that you completely shut the user out from the real world and give them access to this virtual world where they can do things such as perform training, they can interact with 3D objects or even the physics within that environment. Games are quite popular when it comes to virtual reality, but it's not the only interest that has gone into virtual reality. Teaching and learning, for example, has seen a massive adoption in this space. We also have augmented reality known as AR. Augmented reality is different from virtual reality in that the user is not removed from the physical world or the real world. Instead, what happens is that the device actually superimposes data over the real world. Now, a typical example here is Microsoft's HoloLens, which is a set of goggles and allows the user to still have access to the real world while overlaying a digital layer of information. And this could be things such as text messages, UI, directions, all of those kind of things. And then lastly, we have mixed reality. Mixed reality is fairly new and involves a blend of both virtual reality as well as augmented reality. We also have XR, known as extended reality. And the idea behind XR or extended reality is that it is an umbrella term to encompass all of these technologies. Excellent. Now, this is definitely worth mentioning. As part of your course material, you will have summary notes available to you with every lesson that we cover in this course. Now, I believe this is an excellent opportunity to review our skills progression and also get an overview of what to expect throughout the remainder of the course. Now, we'll focus largely on the fundamentals of technology in Module 1. So this is going to be very theory heavy. We'll discuss things like the principles of technology. We'll also learn more about hardware and software, even though we've just touched on the very basics in this lesson. We'll then move on to databases in one of our lessons in this module. And we'll have a practical here just to demonstrate how we can actually work with relational databases. Next, we'll move on to technology trends in organizations. And we'll have a look at innovative technologies in greater detail. We'll then move on to usage in industry from a project management perspective, even though in this lesson we briefly covered some of the usage of innovative technologies currently being used out there. Now, we've also had a look at the fourth industrial revolution, but again, we've done so very briefly. As we progress through Module 1 especially, we're going to go in depth on some of the topics we touched on before. Our next big core topic for this course is IT project management. And again, this is going to be a big focus in Module 2. The idea here is to study IT project management as a whole, to identify several useful tools for IT project management, and then the software development lifecycle, which is core in any IT project management setting. Then we'll move on to tools in software development, where we'll have a look at programming languages. This includes both for the web, for gaming engines, and even for mobile applications. We'll then have a look at some useful frameworks that you might want to consider as part of your software development process. And then we'll move on to prototyping. Prototyping is going to be really exciting. As mentioned before, in prototyping, I'm actually going to introduce you to Just in Mind, and we'll spend a couple of lessons designing a working prototype of an e-commerce application. And then lastly, we'll focus on front-end web development in our last two modules of this course. Here we'll focus on things like the introduction to web development with a bit of theory. And then once we've covered all the theory, we'll move on to HTML, CSS, and JavaScript. Now this is going to be hands-on. You will be coding from scratch. And I hope all of you are looking forward to this part because it's going to be exciting. And then lastly, we'll wrap things up by developing our functional website at the end of this course. Here we'll also spend a couple of lessons and we'll bring together everything we've learned in HTML, CSS, and JavaScript as a final project. And that brings us to the end of our very first lesson in coding and technology. I hope it was a really exciting one for all of you as it was for me. I really look forward to seeing you in our next lesson, lesson 2, where we'll focus on ubiquitous technology. And this includes both mobile and web. So for all of that and more, I'll see you in the next lesson. Cheers.